This work focuses on efficiently learning a policy to control a quadrotor using only visual features. Despite the availability of large-scale simulation, reinforcement learning can be time-consuming and inefficient. This problem becomes worse when using visual features, leading to training times of hours or even days. We investigate, using differentiable simulation to speed up policy optimization for vision-based control. In our training environment, a neural control policy observes the pixel coordinates of visual features provided by a differentiable observation model. It generates body rate and thrust commands, the control inputs to the differentiable dynamics. At each time step, a reward is received depending on the agent's performance. The full differentiability of our pipeline allows for backpropagating gradient information through entire rollouts, enabling the calculation of low-variance analytical policy gradients. To reduce computational cost and hence, speed up the policy optimization further, our quadrotor model comprises two internal parts. A detailed model in the forward path minimizes the simulation to reality gap. However, during the backward path, a simple model is used, reducing the number of operations and memory requirements. To guide implicit representation learning during training, we propose pre-training the policy network on state reconstruction, where the network is tasked to predict the quadrotor state from feature observations. In contrast to model-free reinforcement learning, learning in differentiable simulations solves the task within a training budget of 1,000 iterations while being even 40% faster in terms of wall clock time. After only 9 minutes of training, the policy can be transferred zero-shot to the real world. From varying locations, the policy steers the quadrotor to the center and stabilizes it, observing only virtual visual features. In a second experiment, the policy needs to recover and stabilize the quadrotor from a manual throw. It successfully demonstrates robustness in successive trials.